if you had to pick one word that summarizes what the third law is about, what would you pick? Equal?
Opposite.
Opposite? Oh, it's a bit tough if I only give you one word, right? If it was two, it'd be easy. I think reactions is getting at the heart of it, because then we use our word equal and opposite to describe it. Okay. So, what's the actual summary? I'm not going to give you the full wording for this one because it's quite famous, but the idea is that object exert. That's a really important word. That's the word that we attach to forces. Okay. Equal force on each other in opposite directions. So there are remains two keywords, right? Equal, opposite. Okay. I think the particular wording is for every action there is an equal and opposite reaction. Okay. So nice simple example of this is if you got two things, right? Like say two planets. Okay. So look, or maybe a sun. Okay, and a planet. Actually, no. I take that back. Let's go back to a planet. Let's make it, because this is an easier pick. Let's make it the Earth and the Moon. Okay? Earth and the Moon. Now, quite obviously, the Earth is pulling on the Moon, right? Which is why the Moon is stuck in orbit around us. We know this is an obvious fact, right? So there's a pull from the Earth on the Moon. Yes? But at the same time, the Moon is pulling on the Earth, right? Now, we have so much more mass in proportion to the Moon that it doesn't seem to change us all that much, but it does change us in a visible way. And if you go to the beach, you'll see it. What's the way? Tides. Thank you. So the water around the planet, I mean, this is a terrible overexaggeration, but the water around the planet is a lot easier to move than like all the rocky, hard stuff, right? So that gets bulged out this way, or bulged out whichever way the Moon is, okay? So the Moon is also tugging on the Earth, okay? And in fact, it's actually wrong to say that the Moon orbits the Earth, because the Moon doesn't orbit the Earth. The Moon is orbiting, if you take the masses of these two objects, right? This is so much more massive, but you know, you add them up, then somewhere in between here, there is what we call, you know, if you added these two objects together, there's the center of mass of the entire object, of the pair of objects, okay? Now, because Earth's so big, the center of mass is actually within the Earth, okay? But the point is that the Earth is not just spinning on itself, it's actually kind of wobbling a bit as well, right? The Moon is orbiting that spot, but so is the Earth. The Earth is wiggling around on this point too, right? And so obviously, you know, if you had a bigger object, bigger, you know, more equally matched objects, the center of mass would not be on either of them, it would be right in the middle. So these guys are going to be going around and around. It's not going to look like one's going around the other, because they're both going around this thing, okay? Center of mass, it's called a barycenter. Okay, now, sorry, an equation. Equal, opposite forces. Really easy equation. If you got object A and object B, right? One of them has a force, it's equal and opposite to the other force. That's it. That's the equation that's going to be the starting point for a lot of questions.